At this time, I'm happy to present a panel discussion about the IPv6 launch day 10 years later. And here they come. Please welcome to the stage panel moderators Jan George and John Brozowski. Thank you. I'm sorry about that. Jan will introduce the rest of the panelists.
Here's one me.
You're welcome. Jan is VP of 6 Connect Labs and has traveled to us from Slovenia to join us on stage. This is Jan's second time on stage today. Welcome back. John is passionate about scaling infrastructure and platforms while being obsessed with customer experience and value. John is one of the original organizers of World IPv6 series of events and has led to one of the largest deployments of IPv6 globally.
Thank you.
Somebody has slides. One of you guys has slides.
Yep.
This is the clicker.
We have some recordings, right? So panel format. We have 3 folks who are remote.
Yes.
Right. 4 panelists in person.
Some water over there.
Let me introduce our speaker. Hello, I'm Jan George. Thank you for introduction.
You're welcome, Jan.
And John and I will try to moderate this panel. Here are people that did a lot of stuff for IPv6, and we are commemorating 10 years
Microphone
of this stuff. Oh, okay. So this one doesn't work, apparently. Okay, right. So please welcome. We have Ron Brosma remotely. We have Jason Fessler here, Madhura Kale here, Eric Nygren, Paul Saab, Mark Townsley here, and Matthew Wilder here. And since this is a hybrid meeting, we will have alternating presentation from remote and in room. So the first part should be more of a retrospective. As you all well know, 10 years ago, we did this World IPv6 Day. Well, that was 11 years ago, when we switched on IPv6 for one day and then switched it off. Some people left it on. And then the year later, on 6th of June, we had this World IPv6 Launch, which was destined, and the purpose was to basically switch on IPv6 and leave it on for good. So I would like to ask, let's see who's first. Is it Jason? Yeah, Jason, please, in 5 minutes, if you can describe what you did back then and what happened up to this moment.
Sure. 10 years ago, I was working for Yahoo at the time. The days, months, a couple years leading up to the World IPv6 Day event, Internet Society got all of us into a room. They kept saying, figure out how to make IPv6 move forward or we're not letting you out. I blame Phil Roberts for that. And the resistance to this, as we heard earlier, was the brokenness problem. It turns out it is a small number. 0.05% of the users had IPv6 configured, but misconfigured, or transit was broken, or just something wasn't right, and the kernel didn't know that it wasn't going to work. And so connections would try to connect, stall, and from a user perspective, the site was down. None of us really wanted what turned out to be 1 million users unable to reach, unable to get to their favorite content, to complain about it, and go to the competition. With ISOC's help, we came up with the idea of the World IPv6 Day, where we basically all agreed, let's jump off the ledge together. User won't be able to reach Yahoo, won't be able to reach Google, won't be able to go to Facebook to complain about it. Maybe they'll see there's this hint that maybe there's something wrong on their end. Moving forward, the V6 day was coming up. Those of us that were content providers all ran campaigns to detect the users that are broken, to put up some type of messaging to them and say, hey, we know that you're going to have a problem on this particular day. Click here to learn more. And the campaign worked pretty well. It dropped the brokenness from the 0.05 small number to a much more manageable 0.02 leading up to the actual switch. The day was pretty good, mostly uneventful, other than watching lots of graphs. There were a few hiccups here and there that everyone had, but for the most part, we weren't fired.
And the internet didn't melt down.
Yeah.
So World IPv6 launch came about next year. The numbers were small enough that everybody was happy signing off and saying, yes, we know we're going to have this impact on this number of users. We got to move forward. Coming from a slightly different perspective, I run this little site called testipv6.com. One of its jobs is just to detect broken users. In fact, its only job, really. And that might be because of MTU or any other issues. And one thing I've seen in the last 10 years is, ahead of the launch, we had something like 3% of the users, not the 0.05, but 3% of those who came to the site had problems that we were able to say, hey, you are going to break. And by the time the V6 launch came around, those numbers were down to about 0.6. Still much bigger than what the broad numbers were, because these people are the ones that said, I might have a problem, let's go look. And then over the following couple of years, things went down to about 0.2. It stayed there until about 2 years ago, and it's actually been rising back up since, about 0.7. Looking at the numbers, I've only been able to look at the stats for the last couple of weeks because of GDPR data reasons. Unusual amounts of interest coming from China, Japan, Brazil. An order of magnitude higher amount of interest coming from those locations compared to what maybe Jeff Houston's stats would show from APNIC. Looking a little bit closer, I was kind of expecting maybe it was China that would have the most brokenness because of technical, political boundary issues. Actually, no, they were only 0.2% broken. It was actually Japan at 2.5%. Why 2.5% today? I don't know. I don't know if it's the walled garden issue still rearing its head or what. They do have a high amount of V6 deployed, but can't quite explain all of it. It sounds scary. The reality is that Happy Eyeballs did save the internet, as far as I'm concerned. Happy Eyeballs, for those that don't know, it just basically says run one connection. After a certain amount of time, run a second connection and let them race and remember which one wins. That has evolved over time. We had, backing up, we had implementations in Chrome and Firefox on the day of the launch. We also had OS level support in Apple's Mac OS and iOS. Since then, curl has added support, which is great for scripting languages. And Apple sent or posted an updated algorithm for Happy Eyeballs to help reduce the appearance of latency for the user. So today, nobody really notices they're broken until both protocols are broken, which is cool, but we do still have some troubles that we need to resolve.
Thank you, Jason, and thank you very much for test.ipv6.com. This is really, really useful stuff and helped to debug many, many, many cases.
I remember the meeting when it was created.
Yeah, and when we wrote a document how to use it as a RIPE document. That was cool. All right, let's move forward. Eric Nygren is recorded. Do we have a recording? Thank you very much. If you can.
Hello, my name is Eric Nygren, and I'm a fellow and chief architect at Akamai Technologies. I've been at Akamai for almost 23 years now. As a large content delivery network, Akamai has long been committed to helping our customers with a smooth transition to IPv6. As of the World IPv6 launch event a decade ago, Akamai already had over 1,000 customer dual-stacked host names on our platform. Over the past 10 years, we've seen a dramatic increase in IPv6 traffic on our platform, over 1,000x. Peak IPv6 traffic increased from around a gigabit 10 years ago to recent daily peaks of over 41 terabits per second. We've gone from serving just shy of 4 billion requests per day over IPv6 10 years ago to now regularly serving 1,000 times that, at 4 trillion IPv6 requests per day. While we previously observed 19 million IPv6 addresses per day on World IPv6 Launch, we now see around 7.5 billion IPv6 addresses in a typical day, including around 2.2 billion IPv6/64 prefixes. One way we've been measuring the adoption of IPv6 has been to look at the ratio of IPv6 requests to total requests on subsets of our dual-stacked customer sites. It's worth noting that the typical customer traffic mix, including a set of devices, customer traffic type, and end-user ISP, can heavily influence aggregate numbers, which is why we haven't been reporting a single global number. Looking at the top 10 global economies, all but 2 have IPv6 adoption levels in the 35% to 62% range. And China, while starting out with very little IPv6 10 years ago, in the past few years has seen substantial growth, and now we see around IPv6 adoption levels are around 25%. Growth in individual countries is very much a function of the individual network providers within those countries. Most of the largest networks in the world have significant IPv6 adoption. Around half of the top 100 network providers have IPv6 adoption over 40%, measuring top N by the number of total requests served on dual-stacked host names. Looking at the top 800 networks, only around 1/5 of them have IPv6 adoption over 40%, and this continues to decline from there. A real challenge we face going forward is to convince these smaller and more slowly growing networks to deploy IPv6, even if they have less of a need for it themselves. Otherwise, we face a real risk of a fragmented internet split between large IPv6-centric networks and small IPv4-only networks. Akamai has had IPv4, IPv6 dual stack as a default for new customer configurations for quite a few years now, and we encourage customers to dual stack existing configurations. Many of our customers are large enterprises or other complex businesses that have handling end-user IP addresses deeply embedded in their workflows, meaning that we can't forcibly enable IPv6 for them without breaking things. With this, we've still seen substantial uptake in IPv6 on the content delivery side. Of those customer host names serving over 1 million requests per day, over 40% of them are now dual stacked, and this continues to grow steadily, with many of our largest high-volume customers are now mostly dual stacked. We've even seen cases during large events where the majority of all traffic we're serving to some large countries is over IPv6, and this seems like it'll be increasingly common.
Thank you, Eric. Matthew, what's your story?
Yeah, our story is actually one that's coincidental with NANOGs that have been held in Canada, so this is kind of cool. My very first NANOG was actually NANOG 55, held in Vancouver in 2012. I think everyone descended upon Vancouver that year, 2 years after the Olympics, so I think that year was like, there was an ARIN meeting there, followed by a NANOG, followed by an IETF, so lots happening in Vancouver, and it was coincidental as well with World IPv6 Launch. June 6th fell on one of those days at NANOG in Vancouver, and we did not have the 1% required to have our name checked off as one of the service providers participating in the launch, but we were participating in other ways, doing testing and enabling our website. So it actually took us a few more years to get our residential base going toward V6, and actually it was NANOG 65 the last time I was in Montreal, and my colleague Clinton presented for the audience here about TELUS's experience deploying IPv6 at scale. So yeah, I'd say basically if I look at the story of TELUS and how to categorize our customers, certainly there's a difference between wireless and wireline. We have done some of the T-Mobile playbook of doing V6 and providing V4 over 464 XLAT. So the whole idea of V4 as a service, I think that is definitely the future, and I have to say that I am biased that way because one of the jobs I do in my day job is the V4 address management and V6 address management. The V6 address management is much, much easier. V4 address management, of course, is a somewhat stressful job these days, trying to come up with the addresses for even private IPs on a wireless network with 10 million subscribers. That's not a trivial task. RFC 1918 doesn't quite have enough, and even with 6598 thrown in there. So more and more, I'd like to see the idea of v6 as the default for sure in the mobile space. On wireline, we've got sort of two main buckets, I would say. So residential, as mentioned, we did scale it up in 2015, and today that is the default. So v6 by default, and more we're going to be introducing CGN in order to help scale up v4 as we add customers. And then the other piece is the business side. So business, it's been talked about. We heard it from Scott. The enterprise space is a bit more challenged by inertia and staff being unfamiliar. And one of our design choices in deploying v6, or at least making it capable of that, we decided that the provisioning system shouldn't, by default, give v6 addresses. We want enterprises to basically ask for it. And I would say an analogy is, people in the ARN community have talked about the idea of giving v6 by default to any org ID that's out there. But it's not clear that that's actually going to have an impact on people deploying v6 and using it. So to me, that's our choice. I'd be happy to have a debate with anyone or discussion and hear your thoughts about, should we push v6 by default to enterprise customers? I think it's worth talking about, and I'm sure my fellow panelists have some things to say about that.
Thank you very much. Well, IPv6 by default on or not, we will have a discussion after the retrospective part to continue the discussion that John had with Vint. Would we like to hear now from Ron Broersma? We have a recording, right?
Hi, I'm Ron Broersma, Chief Engineer of the Defense Research and Engineering Network, or DREN, and going to give some perspective on the World IPv6 launch from 10 years ago and the state of IPv6 at the time. DREN was an early adopter of IPv6, so by the time of World IPv6 launch, our backbone was already dual stack for at least a decade. All of our public-facing services were dual stack, and this was part of compliance with an earlier federal mandate. And all our management networks were IPv6 only. And so there wasn't a lot to do in terms of contributing to the launch by turning on something new, because everything was pretty much turned on that was external facing. But we did participate in monitoring and testing as the launch was happening. Some of the issues we had at the time, 10 years ago, a lot of it was with industry products. One of the big issues was lack of feature parity, because what worked in IPv4 didn't always work in IPv6, which really impacted our IPv6 only operations due to loss of functionality. For the things that didn't work in v6, you just lost those functions. So that was a huge problem. Another problem was lack of code maturity. And if you think about it, with IPv4 at the time, we had at least 30 years plus of mature code, but with v6, it was only a few years. And so there's lots of bugs. We're still finding them, and there's certainly more to be found. We had some major meltdowns due to bugs, and so that was our biggest issue in terms of risk. Another problem with vendors in trying to understand why they weren't implementing IPv6 in their products, we found out that they were not eating their own dog food, so they weren't finding out about the issues themselves, and their QA processes didn't include IPv6, and so they were not even addressing IPv6 bugs as bugs, but instead, when they arose, they treated it as a feature request, which sometimes took years to resolve. And so when asked, we said, why isn't this being addressed at a higher priority? They said, well, nobody's using IPv6 anyway. And so there was no real corporate commitment to IPv6 for most of those companies. Some internal issues that we were addressing at the time, our own internal organizations and customers of DREN had a lack of incentive to enable IPv6. We could tell them, set mandates, try to enforce it, but they had lots of excuses. Things like, oh, it's very expensive, and so we need more money, or we think it's less secure, or it has lower performance. And other urgent activities always seem to take precedence, such as security compliance. And the mandates just really didn't help very much, as you all know. There were many mandates over the years, and it really did very little to move the needle. But when World IPv6 launch came along, besides just enabling a lot of the content providers, the search providers, the social media content, it had some side effects that we observed. and that the argument about nobody using it was no longer valid because a lot of people were using IPv6. And the increased demand of IPv6 really signaled industry that they needed to include full IPv6 support, or the companies were going to die because their competitors would win out. And as more people were using it, more people were discovering bugs and pressuring for fixes, which improved code maturity, which just helped the entire community. And also, a lot of the internal excuses about cost, security, performance really proved to be without merit, because if it was good for the many major providers and they weren't having issues with that, then that couldn't be used as an excuse. So it really helped break the logjam in our internal organizations as the excuses went away, and they'd be able to move forward. So still today, what we're noticing, some of those same problems still exist. But as I observe in the federal government, the federal networks, there's still a lack of incentive. And we can easily get bogged down in bureaucracy and other excuses and lots of planning, and sometimes can go on for years without ever passing a single IPv6 packet. And what we also found is there's not much progress unless there's a strong internal incentive within an organization with total corporate support and an IPv6 culture. So having that internal advocacy is really important. So we see a lot of difference between different federal agencies, some very successful and some not doing much at all. But inside the Department of Defense, for the ones that have not yet enabled IPv6, our message is don't be afraid to break some glass, just turn it on. Because all the other excuses and arguments are just a waste of time at this point. For DREN, how we incentivize the industry and also our own internal customers is we do not buy anything from a company that doesn't have a corporate commitment to IPv6. So for example, if they lack an IPv6 enabled website, that indicates a lack of corporate commitment, and we will not do business with those companies. We also turn IPv6 on by default wherever possible. If you're a DREN subscriber, and there are many hundreds, you cannot connect to DREN unless you are dual stack, and that is enforced. And we monitor it. If your IPv6 BGP session goes down, we send out alerts and make you fix it. We remove IPv4 wherever we can, which isn't as many places as we would like. We'd love to turn it off altogether, but there's just too much other legacy and external stuff that requires v4 and is v4 only. So we can't do that yet. But another incentive is we try to make it a security issue, which does help progress a lot, because if we make that part of security compliance, then v6 gets turned on. So we've done that in a number of places very successfully. Some of the continuing challenges are new bugs in mainstream products. We have a major firewall vendor that we've been fighting a bug for the last 3-4 months, and it turned out to be an IPv6 bug internally. And this was bug that was introduced in a recent version of a very mainstream vendor product. So they're still popping up. There's also new products with no IPv6 support at all. Recently, just a few days ago, talked to a vendor evaluating a very new product, looked very exciting, and then we asked the IPv6 question, and well, sorry, we haven't done that yet. So that still happens a lot. And then a big one for us is IPv6 in the cloud, GovCloud in particular, where the IPv6 rollout is just not mature for many of the cloud service providers. So in summary, I think we need another IPv6 day of some sort. We need to reach critical mass. We need more of the internet to be v6 enabled. I need to be able to turn off v4. And so whatever we can do to get there would be great. So thank you very much.
Thank you, Ron. Ron was always famous for chasing vendors to fix IPv6 bugs. Well done. Yeah, Madhura, what happened in your world in the last 10 years in IPv6?
Great question. This is called the reunion tour. I am on a union tour. This is my first time at Nanog. Really excited to be here. 10 years ago, I was actually working at Cisco Systems, testing IPv6 for Comcast. So I was probably somewhere a little minion helping your cause, John. And fast forward 10 years later, I now work at AWS as a manage a product team that focuses on our IPv6 roadmap. But let me talk about what cloud has done in the last 10 years with IPv6. The first time we launched, I might go through some basic cloud things, so please pardon me if you already know them. We started AWS with two primary services, S3, which is our storage service, and EC2, which is our compute service. In 2009 is when we launched something called Virtual Private Cloud, which is like a little wrapper around your EC2 that says, okay, now you're in a private network, and you can use RFC 1918 space in there. Then obviously, a few years later, 2016, is when we started building services that are load balancers. We built Route 53, which is our DNS service. We built CloudFront, our content delivery network. And we realized that, hey, our network that is now facing the internet, no longer a private network, needs to have v6. So 2016, we did a barrage of every service known then that faced the internet. Supported IPv6. So all the services that I named, along with several others, anything that is on the edge of your network can support v6. And we thought, we did a good job. We gave ourselves a pat on the back. And as Matt said earlier, it's an enterprise world. We've handed folks IPv6, and they said, hey, you can turn this on now in your network. That was 2016, early 2017. Now, in the last 2-3 years, however, we've seen the landscape or our customers' needs change. In what we now hear from our customers that run very, very large networks is the internet scarcity of IPv4 isn't as big a challenge for them as it is to run their private networks using unique RFC 1918 space. So if you look up some of our customer references, they'll talk about how they use NATing in their private network. I have a sticker now from someone at Nanog that said, less NAT, more v6, and I took some for my team also. But we have customers that are running out of space within their private network setup, whether it's their virtual private cloud or their extended entire on-premise network with their data centers, branch offices, etc. And then coming with technology that is a few years ago serverless and then containers, we basically had our customers use up their IP space in their VPCs pretty quickly. So anything that we have done now is since 2016, 2017, is to help their applications, whatever our customer enterprises are building, turn that to v6. So now if you look at a simple 3-tier architecture, you have a web tier, app tier, database. Now on AWS, you could build all of that load balancer, compute, database services. You can build all of that as dual stack. So you could build those architectures and applications using IPv6 end-to-end, where a v6 only client could be communicating with all of that without translation needed. And on the other side, for these customers running containers, what we've built is a couple of areas where we've actually built v6 only support. One is just on pure EC2, so you can actually spin up an EC2 instance today that with only a v6 address. And we've also built support for v6 only on our Kubernetes service, our managed Kubernetes service. We did a cool thing where there's an implicit NAT going out to upstream world where v6 is not yet supported in Kubernetes, but you can run pods on AWS, Kubernetes pods on AWS without using v4. So that's been our journey so far.
Excellent. And we will talk later about IPv6 on by default, right?
We did that. Yes, sorry. Thank you for the reminder. We did do that with one of our smaller services. So this is not enterprise. This is our service called Amazon Lightsail. It's also an AWS service. It basically does virtual private servers, so web hosting, lightweight applications that you want to build quick and dirty. So these are not enterprises that use this, as smaller companies. And when we enabled IPv6 for Lightsail in 2020, January, I think, we turned it on by default. So now all Lightsail instances are dual stacked by default. We did have a couple of issues. We were able to fix them. There's some additional documentation you'll find on our website to add additional config to make it work fully, because there's some software packages that the instance, like if you're trying to host a certain type of application, you need to download software packages from destinations that may not work completely. So there's additional config added, but no issues so far.
I think we should move this part of discussion into the next
Segway?
half,
Sounds good.
because now we need to hear from Facebook and Paul Saab. Do we have a recording?
So I'm Paul Saab. I've been at Facebook for about 14 and a half years. And I, along with a handful of other people, worked on the launch of V6 for the public internet about 10 years ago. You know, since that time, you know, we've talked about publicly the work that we have done with V6. And most famously was the time that I disclosed that we had converted all of our infrastructure internally to V6. That process took us approximately about 18 months. And it was fraught with many, many, many problems. We had to get the switch vendors to fix their bugs. We had to fix Linux and other operating system bugs. We had to work around bugs in various libraries and software that we had either written internally or were using in the open source. We had to figure out logging mechanisms. We had to figure out abuse mechanisms. There was, you know, quite a bit of work. And at times we felt like, you know, this project may not work. But at the end of 2014, we launched our first internal data center as a V6 only base. And, you know, we thought we were ready. And when we tried to start taking traffic, it didn't work because we didn't actually find everything that was communicating over V4, because the infrastructure we had in place was not able to detect the minuscule amounts of V4 that was still being served. But, you know, we rolled up our sleeves, we continued to work, and a few weeks later, we launched the first ever V6 only data center infrastructure. And today, really the only V4 space that exists in our data centers is to support public-facing internet infrastructure. So since that time, when we finished all of the work for internally, we've made it our mission to make sure that everything that we launch is dual stack. We have pushed our Facebook caches out to the world, and we try to encourage all of our ISPs that use these devices to use V6, and we will fill over V6. We really have embraced the V6 first strategy. I won't say it's been easy, and I won't lie to you that there are some, you know, building management systems out there and other very esoteric pieces of equipment that still haven't migrated. But we continue to push on this constantly and try to encourage the world to shift to V6. We have, you know, launched V6 networking at scale conferences. We held a couple of those. We've published data on facebook.com/IPv6, where you can track how V6 traffic is, you know, growing over time on Facebook. We continue to monitor new ISPs that are coming online with V6. And, you know, most recently, Verizon Fios has finally started to deploy V6. And as of today, they have gone, you know, from the beginning of from their rollout starting in about April, they have gone from about 2% to 8%. Probably by the time we actually host this panel, they'll be well on their way to over 10% of the traffic. And that's pretty exciting news because people have been asking Verizon since the launch for V6. And maybe they were doing this in anticipation of this anniversary, but, you know, we still have a long way to go. There's still many, many large ISPs in the United States that do not support V6. But we continue to encourage them. We continue to push them. You know, I wish they were more like all the mobile operators. You know, in the United States, we see about 90% of all mobile traffic as V6. So, we've come quite a long way to seeing the world, embrace and grow on v6. Today, globally, 33% of our traffic to the internet is over v6. I would like that to be higher, but in the United States, we're hovering around 60%. India is blowing away the world with Reliance Jio as well over 90% of Reliance Jio's traffic over v6, and India serves up the most v6 bits on the planet these days. So, for us, we believe that we can't scale the internet without v6. We believe that v6 growth is super healthy, and we are here to help any ISP that wants to make sure that their rollout is going well. We can work together. So that's basically, what we have been in the process of doing over the last 10 years is just making sure that all of our infrastructure is well supported on v6 only networks. We really don't deploy anything inside that, requires v4. And so that is our message to you, is that you can deploy v6 only enterprise data center networks. You can even deploy v6 only inside of your offices. That's one other thing. It's not this scary thing that everybody seems to think that it is. We have done it. We did it with a small team, and I encourage you all to do the same. Thank you.
Thank you, Paul. Well done. Mark, tell us everything.
My turn. My journey on, talk about the retrospective first here, and then I'll stand up and talk a little bit about what you see on the slides there. I currently work in the Meraki business unit of Cisco, but I've been at Cisco since the late 90s. I was at Cisco, but pretty much working for the IETF back in 2008. And I was area director in the IETF, so spent most of my time working on IETF things. And it kind of like this, in one of these forums, Google was sponsoring an upcoming IETF meeting. And we were all testing IPv6 at the IETF, because of course the IETF had IPv6. And I said, well, we kind of need some content on v6. I said, Google, next IETF that you're sponsoring, why don't you give at least this conference quad A's? And then after that plenary session, a guy walked up to me who's now my good friend, Eric Klein. He gave me his card, and the title on it was IPv6 Guy. And he said, I emailed Vint, we'll do it. I was like, okay, well, that's the start of something, okay. And then he talked to his friends at Facebook, at Yahoo, et cetera, et cetera. We pulled in John, we got the ISOC there, and we had a community. And just as we saw this morning with Ukraine, a community can be powerful. And how much more powerful was it when Yahoo could go and say, hey, the Google guys are doing it, right? We got to do it too. Or, Comcast is doing it, we've got to do it. Or AT&T would say, Comcast is doing it, AT&T's got to do it, so on and so forth, right? It was so much easier when you had a community behind you. So it led to a great period of time. Now, when we were engineering this whole social community technical thing, getting the big content and the big ISPs on board, right? There's a few engineering control points that have massive effect because of automation and scale, right? And we were able to create that measurement system where we see the numbers go up on the internet. But enterprise, right? To your point earlier. What about enterprise networks? And the graph that you saw from Scott Hogg, the famous Google one that goes up like this, everybody knows why there's a widening gap of this 7-day period with a little bit of like holiday you can see COVID in there. It's basically when people go to the office, they don't get v6. Despite the great work Ron Bursma did at DREN, not every enterprise has a Ron Bursma or a Jan Zors or somebody to make v6 go, right? So when Meraki called me in 2019, and I was still working on v6. I had the chance during the launch to kind of spearhead the movement of Cisco's operation and participation in v6. Still loved it. It really wasn't my day job, but they called up and I was like, aha, this part of the business might be able to make a difference for enterprise. If you're not familiar, Meraki is all about making complex things simple, complex networking technology, IT technology simple. And they do it by allowing their equipment only to be managed from a cloud, from a web interface, right? You're not allowed to SSH into the box. This also means that firmware updates can be sent out, and so on and so forth. So I thought, aha, if we can get Meraki to do this, maybe we can make a dent in enterprise deployments, just a bit. So my goal is to get that widening sawtooth to come down, and we'll do as much as we can with Meraki. So Meraki calls, says, we want this v6 thing, and we're serious about it this time. And I said, okay, well, you're going to have to bring these couple of engineers of mine that I've been working with on v6 forever, move us all to San Francisco, and we'll get your IPv6. And they said, okay. I almost didn't expect it. I was living in Paris, France at the time. I had a great job at a research lab in Cisco teaching. But we went. And the first thing they did for me is handed me a designer. 20 years at Cisco, never had worked with an artist, okay? We would argue over CLI, and we had a parser police and all that kind of stuff, but this was a designer that really didn't know much about networking. He's a great artist. Put us in a room, and we had to hammer out how to make v6 simple. And if you don't make it simple, you don't ship it. We also had to make it work across the entire stack. Now, Meraki sells routers, switches, access points, now cameras, IoT devices, all sorts of stuff. The access points and the switches in layer 2 mode could kind of allow v6 to go through them. But really, it's about the blocking pieces was the MX, which is our router/security appliance that sits at the edge of the networks and touches all the ISPs, as well as the dashboard product. And I really wanted to be data-driven and deployment-minded. And I realized I should probably go to the next slide.
Green one.
Which is next. So that's where you see in 2019, it literally says, hired industry experts. That's me and a couple of engineers from Paris. We wanted to show that we were really serious about this, and we had to turn on Quad A's. It was one of the easier things, actually, to do for our cloud. We own and operate our own cloud, top to bottom. And so we have good engineers, and they were able to get the Quad A's up. Then, it was like, I've got the designers. How do we get v6 to work across the entire stack? And the router product, the MX I talked about, was really the blocker. And the reason was we basically had to write neighbor discovery, and it doesn't just use Linux, right? So we had to write neighbor discovery, DHCP v6, all of it from scratch, which allowed us to also embed it and make it work more seamlessly. Looking at these things. So you see the MR and the MS and the MX. So a little bit of data here. I wanted to be deployment-minded and data-centric. So the first thing we did was started releasing firmware that would actually see and process an RA from the uplink. And usually we're plugged into either residential or business ISP service providers. If we see the RA, we assume we have v6, right? So we start collecting that data because all of our products are connected to the cloud. There's no exception. And that's what you see for this very long time. This is the number of Meraki MX connected to an internet service provider that has v6 on the uplink. And we had very small, very small, very small, very small. And then as you've seen, once you turn it on, you realize oof, there's quite a lot of ISPs out there with IPv6. So this number passed, just in the past month or so, went over 1 million MX with IPv6 configured on their uplink. We've got, that's more than 50% already of MXs that are active and in use today. So that's because of all the hard work that the ISPs have done, all of you have done, to just make v6 available by default on so many uplinks. So how do we make, now that we've got v6 on the uplink, how do we get it down to the endpoints? Well, the only way to do it is on by default. So that's the strategy we took. So if you go in, well, first of all, the WAN uplink. This is kind of what you see. There was part of what the designer told us was, we don't want to have like IPv6 and IPv4 modes. We want it to be kind of built in. And those little black dots things on there where we obfuscate the global IPv6 address. It's necessary when we do public presentations. But this is an actual screenshot of what you get in released firmware today if you have an MX. If there is IPv6 on that uplink, we show you there's IPv6 on that uplink. And there's no way to turn it off. You can turn the whole link off, but you cannot just turn off v6. It's always there. And we figure it's better, even if you don't want v6 on your LAN, it's better for you to know it's on your WAN than for us to drop it silently or something like that. So we don't allow you, we don't not tell you it's there. We tell you it's there always, and you can't turn that off. Now, that's like when you first plug in the box. Then you have to configure the LAN side. This isn't residential, it's enterprise. It's maybe sort of not your, well, we have very big customers, I don't want to say that. Anyway, it's not consumer, but it's still, you have to configure something. And you have to create a LAN. And when you create a new VLAN, because you can have, of course, many virtual LANs, you basically have this, it's kind of hard to read, sorry. On the upper left side of the screen, you have this, that's, I'm creating a VLAN. I name it, I have to give it a number, then I hit next. And then I have my v4, and you have to configure the v4, but the v6 is enabled by default. And we can have it on by default because we can get prefixes from the ISP via DHCP v6 PD. We can put them in a pool mapped to the WAN that we received them on and give them to the LAN. You don't have to configure anything if you don't want to. And then you're done. You have v6 by default. So we're expecting, now that we have the firmware that has both WAN and LAN side, that we're going to get more and more and more adoption over time on the LAN side. For existing VLANs, we wanted to make it as simple as possible as well. It's actually 3 steps. 1, you have to say modify. 2, you have to say enable, and then you're back to that same view where it's all enabled by default. The prefix delegation page, we have a new tab there where it's basically telling you, we're in this new world where we're getting delegated prefixes from ISPs. And if I have any request to the ISP community, is to please give those delegated prefixes. We're building this not as a NAT box, but as a router. We're trying everything we can do here to make it as easy as possible and also to not NAT. What that means is we gotta have delegated prefixes. A /64 just isn't good enough, and Lord knows a 128 is terrible. So when you enable on the LAN side, we start asking on those WAN sides, give me a /56. If you don't give me anything, give me a /64. This is probably one of the most complicated things that we do to make it simple for the end user, right? But we do that to grab as many prefixes as we can, and then we start assigning them to the LANs, and we will even split them up if we run out. And we try to use them efficiently, but there's a point where maybe if you've got 1,000 VLANs, you're going to run out. And then what do we do? That's where it stops being simple. That's where you have to start, a human has to go, okay, do you want to put ULAs on or not? And you can manually do this. Then when we route the packets, we remember if they were delegated prefixes from a WAN, and we will send them out the correct WAN. But if for some reason that WAN's down, we'll NAT it to another WAN because of BCP38. But all of that complexity there is there to keep it simple for the end user. 1 minute, okay. So you see some of those land size prefixes. If we were zoomed in there, you would see this cute little 4 and 6 with a hexagon for 6 and a square for 4. That's some of this artistic stuff that gets built in. And the ACL page is even better, where we build the v4 and the v6 together. So you can create a rule, one ACL, if you wanted to apply for v4 and v6, so you don't have to keep them separate. So again, all this work to make v6 enabled by default and to make it easier to manage. So we keep posting updates out there, and I hope this, and I want to come back and give another presentation at some point where I show the data on the LAN side of the adoption that we're getting end to end. I expect it to be like we've seen from our residential providers, that when we turn it on, it's there, right, on the endpoints. And we've started turning it on, but it takes time for the new VLANs to come online, because we have more existing VLANs than new VLANs, right? So what we want is to track all this and see how it's being used, and at some point in the future, to be able to enable it on all the VLANs with a notice. It'll be like an upgrade. Oh, and by the way, you're going to get v6, right? And then watch the v6 and start bringing out technologies that allow us to take v4 off the LANs and just walk the customer through that journey with easy by default types of steps. And hopefully that can be a pattern for other vendors and other enterprises to follow. So
thank you, Mark. So
welcome.
When you spoke about power of the community coming together, and since we had IPv6 Day and IPv6 Launch, do we need something like this, some more events, one new event with peer pressure to maybe put IPv6 on by default and use the same mechanism as we did 10 years ago to move the needle forward? Maybe, John, will you?
I'd love to. Thank you.
Love this discussion.
I don't think I've stayed this quiet this long in a long time. So I'm happy to chime in here. I mean, friends, longtime friends. I mean, in some ways, a lot of what we're hearing here was old is new, right? Gradual enablement, turn it on gradually, uplink.
I learned it all from you.
I love you, man. I love you. And I'm a little emotional right now. Not really, but kind of figuratively. I think about the conversation I had with Vint. I had the pleasure to see him in person a few weeks ago to prepare for the video we did this morning, and we were kind of talking about this. 10 years later, lots of progress, but we still have a long way to go, right? I had the honor to come back here in the fall, and I kind of did some, looked at some data. By some measures, I mean, it could be another 10 years. But then I hear on by default, Eric Nygren on by default. Paul's been on by default for years, Matthew too, and et cetera, right? So now I'm confused, right? So, and one of the things that I do want to kind of comment on is v6 on by default, just to be crystal clear, is not necessarily v6 only. Someday, hopefully, v6 only. I won't be here, right? Yeah, these guys will be on vacation somewhere on a beach together, but whoever comes to this next, the next generation or two, I mean, yeah, I see that in the future, but the question is burning, right? So what's the problem? I mean, I didn't know many of these things, even though we've kind of tried to maniacally plan for our panel here. We left some room for variability here, right? But there's a lot of news here about v6 on by default. I mean, I don't think we're done. So I want to pose the question to you all. So what holds us back? What hinders us? Are you all disappointed in where things stand as far as v6 is concerned? Let's open that up a little bit and kind of spice the conversation up, so that we can, get some feedback from the audience. Have your voices heard. Thoughts? Jason?
I echo the sentiment for sure of on by default. I think the main message is that when you're turning the service up for a customer, it's okay for them to break on that one little thing because they're not yet production. You're not taking them down, and it helps them highlight any areas that need to be fixed, and if necessary, opt out if they have to, but hopefully, no, go fix it. It's a lot harder to go in and once it's up and running to go and change the knob, because then you're putting them at risk of breaking them. This is, I imagine, true for service providers. It's certainly true for internal stuff at places I've worked at. Nobody wants to touch the thing that's working. It takes a lot more effort to do it after the fact.
On Zoom, I'm assuming the Zoom folks can hear us, right? AB team? Paul, Eric, Ron, thoughts?
One of you.
They're the three that
I think
voted.
the long tail ends up being a real challenge here. Like for ISPs, a lot of the big ISPs who have turned things on by default have had huge growth, but there are a lot of smaller ISPs out there that haven't had that big push or drive or need to enable IPv6 that haven't. And this, I think the same goes across enterprises. And but that also goes across even on the device side. We see that the major browsers and major operating systems all have IPv6 on by default. But when you start getting out into consumer electronics or many mobile apps, there are plenty that either don't have IPv6 on by default or have bad IPv6 implementations. Like we've seen cases where you get the combination of a ISP that has done a poor IPv6 rollout and has some connectivity issues, combined with some smart TV that doesn't do happy eyeballs, and now you have a streaming provider that tries to turn V6 on and starts getting complaints because in some country where that smart TV is popular, users can't go watch their stream anymore, and that content then gets switched back to V4 only. And this is not in the kind of the core set of names that everyone would have heard of, but even those things out at the tail can be enough to be causing real problems that I think are going to be one of the challenges we have to face over the next decade.
You know, Eric, if I can chime in briefly before others do, I used to think the same way. You know, the smaller ISPs, you know, where they at? So my family and I went on a short Easter trip this year. You know, and as I always do, I visit testv6.com. You know, like, why not? I mean, that's what, of course, the first thing you do when you connect to the Airbnb Wi-Fi. V6 enabled by default, Eric. Can you believe it? I couldn't believe it. I was Pentel data. Anybody from Pentel? Anyone? Bueller? No? You should be. Good job, right? So anyway, you know, back to others here. You know, chime in, please. I mean, I'm still confused, right? Yeah, Matthew, please.
Yeah, I mean, I think to a certain degree, like the success of World IPv6 Day and launch were certainly the community that came out of that, the concerted focus around making IPv6 available, getting past those gaps that did exist, or at least we thought may have existed. And to me, I think where maybe we need to see some more traction is outside this community. I think the folks mainly in this room have understanding, and they've done their part in many cases. I think it's the long tail. It's the long tail of that Pareto curve. You know, I think it was Scott who had that slide up, the top 1 million websites, something like 20% are V6 enabled. So I think it's kind of that long tail, and maybe CDN plays a role. Maybe there are other pieces where there's choke points that can have an amplified effect. But I think to some degree it's still outside this room. It's consumer electronics, apps, that kind of thing.
So Matthew, question for you. So service provider, right? You know, I've been there, right? CGN, you talk about CGN, you talk about V4 as a service, MAP-E, MAP-T. I mean, still provides V4 connectivity. It's different. And I do want to get back, if the gentleman's here from Netflix who asked the question in the previous panel, I would like for you to come back up when we do some open Q&A. But my question to you is, what do you think? Do you think that would be a motivator? Do you think that would change the game? I do have a follow-on comment on that.
Yeah, no, I think CGN for sure is going to be the future more and more. And I think one way I look at it now is more and more customers served by CGN, but I want to see less and less traffic served by CGN. So that means identifying what is the traffic that's relying upon it that could be going V6 that's not, and why is that, and let's tackle that.
Great. One comment, and then open it up again. So to the Netflix gentleman who was at the mic last time, there was a comment around V6 was broken. The first step was to turn off V6. What I have found personally, when you use it to run your business, like operate a cable modem, for example, like you make sure V6 works. Period. You don't have a choice. Otherwise, the rest of your services don't work. When there are ships in the night, that ultimately creates the greatest opportunity for things to get out of sync and broken. Back to you all. Either in person or.
I have one thing to add.
Please,
on the challenges you asked earlier. What are the challenges to get V6 on by default? One of the things I would love to know from you, like how Mark in his presentation said, V6 on by default in new VLANs. Existing VLANs, you can enable it. We have the existing enable option. We don't have a new by default. I guess what I would love folks' inputs on is how do you define new in a world in the cloud where you can literally spin up new in seconds. It's all scripted, and your load balancer, a new load balancer, is basically the same one replica running an entire production traffic. And that new is no longer new because it looks to us as new, but it's really an existing application that has live traffic on it. So not necessarily to you, but that's one of the challenges that we sort of think about. So how do you define in that world what that new identity is, where you say in this new box, it's safe, versus like the old box, not so much.
Interesting. Mark?
Well, from Meraki's standpoint, and maybe this can translate into the AWS VPC creation or some such, is that essentially anywhere we can avoid the user having to type in an IP address, we try to avoid it, right? Mm-hmm. And we do that with more and more with V4 as well as with V6. And it turns out that it's actually easier in V6 in a way, right? Because if you have those delegated prefixes, you can use them and do it algorithmically, right? So that's what you saw, where when we're enabling the topology, create the VLAN, we give them V4 and V6, and the V6 is actually easier than V4 in the default mode, right? So perhaps in the VPC, one of the things you said is it's like, it lets you wrap up a customer's cloud environment and give them private addresses, right? Well, maybe with V6 you can give them public addresses, or give them private ULAs and NAT them out of floating V6 if you must. But this is one thing that we're trying to avoid, and it all depends on how many delegated prefixes we can get. I suppose with AWS you could allocate as many as you wanted from your PA space and from your PI space given to them, and maybe they could bring their own addresses, but then we hit the BGP issues. But anyway, that's going down a rat hole. I think there's things that you can do, and we should talk about this afterwards.
Yes.
Just to go through that workflow and try to eliminate as many steps as possible.
Yeah. No.
Awesome. Mr. Saab, I remember in your office, the old one, we sat together side by side, turning on Facebook for some comment subscribers, just like yesterday, right? So what are your thoughts, Paul? As far as, and this is, to some extent, I have to imagine, as close as we've been over the years, this is probably like an old conversation for you, right? So any words of wisdom, thoughts?
The work that we did was like, I have to think it was like maybe 2 or 3 of us were actually leading the project, and we had an excellent project manager that basically sat down with everybody inside of infrastructure and just like kind of forced them. There's a funny story. If there was a team that wasn't listening or wasn't actually doing the work, he would go and sit down next to the engineers and shame them. But he would just sit there and just do his work and just remind them that he was, on their case every day. But for us, V6 is a mission critical part of our business. We could not be scaling our data centers. We could not be scaling anything that we do at Facebook/Meta inside of our data centers. We had to migrate internally to V6 because the other option was we had to renumber V4 all our C1918 space, or go out and buy some public space and use that internally, which we would have been murdered for. And the project, while it was a tough 18 months, and I say tough because there was times where I did not think we were going to be successful. And, we just slogged through it. And Jason is right. It's not easy to take a big moving ship and convert it in flight. But you're also wrong, Jason, in that if you just put a small dedicated team, they can pull off anything. I think Google, Lorenzo, and Eric did most of the work themselves. And so this is like the key to all of the other operators and app developers out there. It's not that hard. The thing that you will probably run into is what Reddit ran into a couple weeks ago when they were trying to test it on their Android app. Happy Eyeballs is still not really well supported on Android. And I think just OKHTTP just got like Happy Eyeballs support recently. We had to go and develop all of that stuff ourselves in our apps and make sure that we were, supporting not only dual stack networks, but V6 only networks. Before Apple fixed a lot of their stuff for V6 only in the operating system, we had to, do the work ourselves to make it work. There's just, I think that we're at an interesting point in that, there's a lot of work that's been going on, and then the long tail just isn't happening. I'll call them out by name because Eric wouldn't. Roku is probably one of the biggest culprits to seeing more and more growth on the internet. They're one of the largest streaming set-top boxes, and they still haven't turned on V6. Even though you, John, have been yelling at them, many of us have been yelling at them for years, it's still not there. And so, how do you get all of these, consumer devices that are sitting in people's homes to turn on V6? Because, a good portion of the residential users, have it. And, we're just lacking, set-top boxes, consumer electronic devices in offices. So, it's really just rolling up your sleeves and doing the work.
Agreed, Paul. Ron, last but not least, words of wisdom, thoughts?
So I've been thinking through the on by default, which we've been doing for a long time. And the thing that comes to my mind is that you can lead a horse to water, but you can't make them drink. And we've seen that a lot where I can mandate that all of our subscribers on DRAN, I can give them IPv6 addresses, give every site a /48. I can mandate that their border router is up on V6, but I don't control those large laboratories and defense contractors and so forth. They run on their own networks, and they don't enable it on their firewall or in their internal networks. I don't control that. So what's the incentive? About the only controls I have is other things they might want to get to inside our environment is start turning off V4, so they're forced to turn on V6. That's a bit of incentive. It works to a certain degree, but I've been frustrated with mandates that don't work, and I've been through a lot of them over the years. I am a fan of flag days, and that might be heresy just because of what it means, but I was there in 1983 when we turned off NCP. It was a huge motivator. I remember when we turned off the 6-bone. I remember when we converted from analog to digital TV. It was a flag day, and it was successful. There was also the DNS flag day just a few years ago. That was successful. When can we have some kind of a V6 flag day where we turn off V4 or start turning it off for real? Set the deadline. That'll be a huge motivator. Maybe that's impossible, but that's what's going to get it done in the long run. So it's something to think about just as the next step beyond turn it on by default. Let's start turning off V4 where we can. So That's my final thought.
I got one thing to jump in here. Hey, on the on by default, because I didn't really answer that for you. When one piece of the network decides to make it on by default, they're doing a huge favor for that other piece. So right now in my job at Meraki, I'm sitting between the ISPs, which by data that I can show my superiors, look, the ISPs already have this v6 on by default, right?
I see.
And on the LAN side, I know that the Apples and the Androids and the Windows and other things have it on by default. So I know I'm sitting there in the middle and we can just turn up the dial, right? What if I had to go and say, okay, now we got to call Comcast and ask them to turn it on for all the Meraki customers, here's the list.
Yep.
It wouldn't have happened.
So being
right?
preemptive, making sure the chicken appeared before the egg actually was extremely valuable in this case.
So this on by default is hugely important. How do we put a day around it? That's maybe a harder question.
Yeah.
But the messaging of on by default, hugely important.
Yep.
It makes it so much easier for everybody else who's trying to make it go.
All right, so we're going to get the hook here, Mark. So I'm going to wrap it up if you don't mind. So lady and gentlemen, thank you so much. Despite our best efforts, Jan, we cut it close. We're this close to being able to take some Q&A. But we can't do that. So at the end of the day, if anybody has questions, we know there's some online. I'll work with the panelists to make sure that we can address them and answer them virtually, right? Yeah. So if anybody here has the same, please channel questions and we will absolutely respond to you. It's been an honor and a pleasure. Thank you.
Thank you very much.
Thank you.